Suppose you've quantified all the costs and the benefits over the relevant time frame. You've discounted them all back to present values. What now? How do you decide which projects to support? There are two main criteria that I'll talk about: net present value, or NPV, and benefit cost ratio, or BCR. The net present value is calculated as the difference between the present value of all of the benefits added up minus the present value of all of the costs added up. And the rule for a good project with this criterion is that you want the net present value to be greater than zero. In other words, the aggregated discounted benefits should be greater than the aggregated discounted costs. Or put very briefly, you want the benefits to be greater than the costs. So that's a nice, simple and easy to understand criterion. The second one is the benefit cost ratio. It's very similar in some ways, but this time we're dividing rather than subtracting. The BCR is the present value of benefits added up divided by the present value of costs added up. And this time the rule for a good project is that the BCR should be greater than 1. But if you think about it, that's basically the same rule as saying that the net present value should be greater than 0. Here's an example to illustrate how it works. We've got a 5-year project. You can see a column of benefits that vary over time. You can see a column of costs, where the highest cost is in the first year or at time 0, and then there's another cost at time 3. We've got a column for the discount factor, and then we use the discount factor, we multiply that discount factor by the benefits to give us the present value of benefits column, and we multiply that discount factor by the costs to give us the present value of costs column. Now we can just add up the numbers in each of those present value columns to get totals down the bottom there. So the total present value of benefits is $37.24. The total present value of costs is $18.27. And from those two numbers, we can calculate the net present value, which is the difference between them, or the benefit cost ratio, which is the benefit number divided by the cost number. Net present value is $18.97. The benefit cost ratio is 2.04. Now, an important question is, which of these two criteria should we be using to evaluate our projects? Is one better than the other? Is one better than the other in certain circumstances? So the answer is the latter. It depends. First question we need to ask is, are the projects independent? Are they unrelated to each other if we're trying to weigh up and compare different projects to potentially fund? If they are independent, what we're saying is that they're basically not different versions of the same project, and you could do them all if funds allowed. So let's suppose that's our situation. We're evaluating projects where they're all independent of each other, they don't affect each other in any way. Then the second question is, are the funds available for funding projects unlimited effectively? And if the answer to that question is yes, we don't really have a serious budget constraint, then the use of net present value or the benefit cost ratio are equivalent, because either way they'll tell you, yes, doing this project generates more benefits than costs. So you can use whichever you prefer. And you won't be ranking the projects because funding is unlimited. Ranking them is sort of meaningless. There's no need to rank them. On the other hand, if there is a limited budget for funding, and that's more commonly the case, then you will be interested in trying to rank the projects so that you know which project is the highest priority for funding, which is the second highest, so on, down to which is the lowest priority for funding. And that will help you decide which projects get the money. But to rank projects, you should only use BCR when there's a limited budget. So the benefit cost ratio is the criterion for ranking projects under a limited budget regime. Let's go back though to the first question of whether the projects are independent. What if we say no to that? What if they are related? For example, they might be different versions of the same project, and which would mean you couldn't do them all, even if funding allowed, because you can only do one. They all apply to the same place, so there's only really space in the real world for one of these projects to be implemented. Doing one rules out the others. In that case, to choose which of these projects to do, we would use the net present value. And our rule is that the best project is the one with the biggest net present value that we can afford to do. Now, this second scenario is quite important because what we're often doing is we're comparing different versions of the same project. And this is a good thing to do. It's always good practice to assess more than one version of a project before settling on which particular version you're going to choose and run with as the preferred version of that project. The reason this requires some thought is that versions of a project that are more ambitious, that have more ambitious targets, can certainly deliver greater benefits, but also may incur, well, they certainly will incur greater costs. And it's not necessarily obvious in advance how you will best strike that balance between the greater benefits of a more ambitious project and the greater costs. So it needs some thought and some analysis before you choose which version of the project to run with. Now back to our decision about which of these two criteria to use. This is a nice little decision tree that summarises what we've been talking about. The first question is, are the projects independent? If they're not, it's easy. We just apply a net present value and we choose the project with the highest net present value that we can afford with our available budget. If they are independent, we've got another question, which is funding unconstrained? If funding is unconstrained, we can apply either a net present value or a benefit cost ratio. It doesn't matter, you'll get the same result, and you'll fund everything for which the net present value is greater than 0 or the benefit cost ratio is greater than 1. But if the funding is constrained, then you're going to want to rank the projects, and you do that using a benefit cost ratio. Now, one other complexity that might come up is if you're trying to compare a range of projects, some of which are independent, but some of which are different versions of the same project. What do we do then? Well, let's assume the usual case that the budget is constrained and talk through how we would handle this. Strictly speaking, there is no single criterion that solves this problem. I can't recommend, just use net present value or just use benefit cost ratio, because neither of them will really give you the insights into which projects you should be supporting. You could use an optimization algorithm like linear programming if you have the skills, but most people don't have those skills. So I'm going to recommend a fudge that you can use to get to a good answer in many cases, even though it's not strictly theoretically definitely correct. And this fudge is first select amongst the different design options, the different versions of the same project, using net present value. And to do that, you'll probably have to assign some notional budget to each of the projects. And then rank the best of the design options using benefit cost ratio. So if you do that, do it in 2 stages, then you can get to a pretty good result. To illustrate how that might work in practice, suppose we're comparing 2 different projects, and for each of those projects we've got 3 different versions with slightly different activities or different scales of activity or different timings, so that they give slightly different results and they have different costs. So for project 1, there are 3 versions, 1A, 1B, 1C, and for project 2, there's 2A, 2B, 2C. In the first step, what we do is we choose the largest net present value with our notional budget that we've allocated to project 1, and it turns out that project 1B is the best using that criterion. And for the project 2, the largest net present value with our notional budget gives us project 2C. Now we want to know whether we should prioritise 1B or 2C to allocate our limited money to. And we use benefit cost ratio for this. And for argument's sake, you might get 2C turning out to be the highest ranked project and 1B the second ranked project. So we're using benefit cost ratio in this second phase, net present value in that first phase. Key points. We've seen that the net present value is the difference between the present value of benefits and the present value of costs, and that the benefit cost ratio is the present value of benefits divided by the present value of costs. We've seen that the choice between these criteria depends on whether the projects being compared are independent or not, and on whether or not there's a budget constraint. Assuming that the budget is constrained, then we would use the benefit cost ratio if the projects are independent, or the net present value if they're not.